Welcome to our video series featuring step-by-step guides to how to use Cruise Pilot. For the purpose of the tutorial, we will be using LEXION 670 to demonstrate Cruise Pilot. In the first section, we will look at how Cruise Pilot works and show you what you need to know about the basic settings. Cruise Pilot adjusts the working speed of the LEXION to the optimal speed of the crop conditions. To calculate this, the system essentially uses 4 influencing variables: the quantity of material in the feeder house, the engine load, the separation losses, and the cleaning losses. The deflection of the middle support roller is used to measure the quantity of material in the feeder house. The crop pushes up the feeder chain and with it, the support roller. The larger the deflection, the more material there is in the feeder house. This allows load peaks to be identified earlier. Cruise Pilot takes into account the separation and cleaning losses. If these losses increase, for example, it reduces the working speed. To use Cruise Pilot, we first need to go to the main menu and call up the Cruise Pilot submenu. To do this, we select the gear wheel from the CBUS main menu, followed by the Cruise Pilot submenu. First, we need to set the Cruise Pilot master switch to on. Next, we must select one of the 3 possible strategies under the chess piece symbol. The first strategy is cruise control. With this strategy, the LEXION always travels at the pre-selected ground speed and keeps the speed constant. Aside from cruise control, there are 2 other strategies that are very similar to one another: output and throughput. With both of these strategies, Cruise Pilot adjusts the working speed in line with the engine load and the material feed height in the feeder house. The only difference is that with the throughput strategy, the cleaning and separation losses are taken into account. This is why we will be focusing on this strategy in the next part of the tutorial. In the next submenu, we can set the target throughput. This is to tell the machine the maximum material quantity that Cruise Pilot will permit in the feeder house. However, a much quicker way to set this target value is by means of a simple learning process that takes place as the machine works. We will look at the learning process in more detail in section 2. If the machine has not been used for an extended period or following repair and maintenance work to the feeder house, we need to establish the 0 point for the target throughput. If there is no crop material in the machine, we press OK and follow the instructions on CBUS. To prevent the combine harvester from travelling too fast, for example in areas of the field with low crop density, we need to set a maximum ground speed here that Cruise Pilot will not exceed. In this submenu, we can adjust Cruise Pilot's sensitivity. Very gentle means the machine will respond slowly to changes. Very aggressive means that it will respond quickly. Which settings we choose here very much depends on our driving comfort requirements and on the crop conditions. CLAAS recommends setting the sensitivity to medium. However, in this case we are going to choose aggressive so that we can demonstrate changes in ground speed more clearly later. With the unloading mode, we can set how Cruise Pilot behaves during the grain unloading process. If we switch off the unloading mode, Cruise Pilot will adjust the ground speed even during the grain unloading process. Because this poses a particular challenge for the trailer driver, we will select the unloading mode. Doing this means that when the unloading process is activated, ground speed will be reduced slightly to begin with and then kept constant. Cruise Pilot always takes into account the engine load. Here we can set the engine load at which Cruise Pilot either reduces the ground speed or stops accelerating.